Carbon tetrafluoride. Hi, my name is Seth Alstrom. I teach honors chemistry at Abilene High. So in the lab today, students are expected to analyze the properties of ionic, covalent, and metallic substances in terms of intermolecular and intramolecular forces. So we start every single class with a review of things that we've had in the past, and it might be the day before, it might be weeks before. Intermolecular forces was the goal of our lab today, and so we covered things that they have never actually seen before in our bell ringer, where they're having to draw on past knowledge to apply it to the future. So when we use our Pauling scale to determine if it's polar or non-polar, what are we actually comparing between?
The bonds.
Okay. Can you elaborate a little further? They were given 5 different unknown solutions, and through a tension test where they were putting drops on pennies, or an evaporation test where they were seeing how fast each of the solutions dissolved, they were trying to determine the strength of each of those different solutions. After collecting that data, they then get to look at extra information I provided for them so that they can try and figure out not only which one of those solutions is the strongest, but also see if they can determine the actual solution that each of those things was. So talk in your table group, see if you can determine of these 5 what is polar as a whole molecule and what is non-polar as a whole molecule. What we do in here a lot is inquiry-based learning. The students are given an activity, the students are given a lab where they have very little background information on what the actual purpose of it is. But through the process of doing it, they start to piece together some of the big key aspects of what we're trying to accomplish. It's all about seeing if the students can embrace the learning themselves, if they can problem solve, because that's what science is really about. It's not the memorizing, it's the doing things, it's the learning things.